Hello, and welcome to my video lecture on biobutanol and its potential to slow global warming and provide a renewable source of fuel for generations to come. But first, a brief intro on biobutanol. Biobutanol, or C4H9OH, is a four-carbon alcohol produced through the fermentation of feedstock. It is similar in many ways to ethanol, such as that both are renewable fuel sources centered around the transportation industry. Additionally, they are both produced by fermentating first-generation biomasses, including, but not limiting to, corn, potatoes, sugarcane, and beets. Biobutanol was produced as a potential solution to the global climate change crisis by cutting the emissions of the second largest sector of greenhouse gas emissions, transportation. Now, returning to the discussion of feedstocks, let's talk about the cultivation of feedstock for use in biobutanol production. Biobutanol benefits from its ability to be produced through different generations of biomasses, noticeably the second generation biomass, such as waste from the food production industry. This means that land doesn't necessarily have to be dedicated to this fuel, as it can use the unused byproducts of farms dedicated to other ventures. However, if first generation biomasses, such as corn or potatoes, were to be used instead, large production centers and farms would have to be dedicated to biobutanol. Along with knowing what feedstocks are used and how they're obtained, it is important to understand how biobutanol is made, which brings us to the next point of discussion. How biobutanol is made. Biobutanol is made through acetone butanol ethanol fermentation, also referred to as ABE fermentation. This is a two-step process that utilizes Clostridium bacteria to convert sugars into alcohol. The two phases are acidogenesis, which converts sugars to acids, and solventogenesis, which uses reabsorption to produce butanol with ethanol and acetone as byproducts. ABE is anaerobic, so no oxygen is required. On to development. It is currently being further researched and developed and has been approved to be mixed with gasoline and up to 16%. New feedstock sources are being researched, along with improved methods of fermentation. Now, on to the impact. Does it do more harm than good? Currently, it shows a lot of promise in cutting carbon emissions. However, there are some concerns. Relatively, it produces low yields. Its cost of production is pretty high right now, more carbon emissions than ethanol, which is not what you're typically going for when trying to cut carbon emissions. And it also has a low heat value, so you need to have a higher amount of fuel in engines to keep it going. However, there are some pros. It has a high energy content and a density, so overall just great energy. It's less corrosive than ethanol, which is one of its biggest problems. It has a better blending and a high compatibility, which means it can be used in lots of engines. It can also be used as a direct replacement for gasoline, unlike ethanol. Now, onto the economics. Feedstocks are pretty costly. It makes up 70% of cost, but if used using the waste, it will bring down costs a lot. The high cost of operation of the respiration facilities is another concern. And the US and Europe, as of right now, decided it is economically infeasible. Now, how well known is it? Well, it's largely overshadowed by ethanol and other biofuels, but biofuel and environmental researchers are working to spread awareness through their research and new studies. It's also growing in global awareness as improved methods are coming up. Now, on to my plan. First, we'll find a cheap feedstock, preferably a waste product. Next, we'll streamline the process to improve yields because that is a major concern of the biofuel. Then we'd improve awareness, which in turn improves funding. Next, we'd refurbish ethanol plants into biobutanol plants because biobutanol is so far better than ethanol. And then we'd set up pipes to transport the fuel in order to cut more emissions by making it to where we don't have to transport it by truck or train. And then finally, incorporate it into the gasoline supply, much like we're doing with ethanol currently. Here's my work site.